So we're looking at a problem where an object is going up and or down now. And we're still treating it the same way, but there's a couple little differences you'll see as we go through it. A dime is thrown upwards with a velocity of 35 meters per second. When I calculate the velocity of the dime, 5.0 seconds later. So what are we looking for to begin with? Which one, initial or final? We're looking for final velocity. Okay, so before we even get to that, all right, reread the question, set up a coordinate system. So this object's going straight up or down. So positive is up direction and negative is in the down direction. Now we go through it again. Write down what we know and what we're given. So dime is thrown up. We have initial velocity right off the bat. So the initial velocity is 35 meters per second. And for a direction, you can just put up. Right? You could put to the right, you could put to the left. As long as you've defined it, you're good. Calculate the velocity of the dime 5 seconds later. So we're given time, 5.0, and we want to calculate final velocity. That's all we're given in the problem. Any issues with that? Or Matt? Where's the acceleration? What? It's like you can read. What is the acceleration? That's why it says here. This is stupid. I'm out of here. What? I'm gonna give up. No, don't give up. These are a lot of problems are worded this way. What is the acceleration? Where is this taking place? What planet do you think? Did you say Trackety? Gravity, yes. It could be a Trackety. I don't know. There we go. Yeah, we need to look at the acceleration of gravity. This is taking place on the Earth. Anytime you have a question where an object is thrown, and unless you're told specifically Mars or Jupiter or anything like that, or the moon, it is on Earth. Okay? So we need to write down that the acceleration is negative 9.81 meters per second squared. Right? And that's relative to going up. So if you it's in your handbook. It's just a number we're going to use all the time. That's the acceleration of gravity if for something moving through the air, but no air resistance, so it's not moving through the air. So this is something you need to remember. Any objects that are moving, thrown, tossed into the air, the acceleration is instantaneously going to start being negative 9.81. As soon as it leaves your hand, it's going to start slowing down by negative 9.81 meters per second squared. Okay? Again, we're only throwing objects up or down, not at an angle. Okay? So now we have all of our quantities. To check for a formula, got it. Substitute the values in. So what made this question is a little bit different is you're not told what acceleration is. It's in your handbooks. It's right in one of your tables where it defines what all your variables are. It's right there. You might see it as a lowercase g for gravity, acceleration of gravity. All right, so let's put our values in. Acceleration, negative 9.81. Final velocity is what we're looking for. Initial velocity is 35 times 5 seconds. Need more space. So again, multiply both sides by 5. I'll do it the Tory's way this time. So 9.81 times 5, it's 49.05. Yeah, right on. It's negative 49.05. That's final velocity minus 35. So the change is negative 49. So in 5 seconds, gravity is going to take away almost 50 meters per second. Add 35 to both sides now. Because the initial velocity was upward, and that's our positive direction. So that's in 5084.05. Equals final velocity. I'm just going to write it again below it with the units and the direction. Actually, we don't need the direction. The answer is positive, so that communicates it's up. Well, sorry, my bad. My bad. I can't add. See, now on YouTube, this is going to be really embarrassing. Yeah, you laugh. All right. So add, yeah, 35. I can't subtract. Could have told me about that like before. I made an idiot of myself online. So what do we get? 14? Point what? I'll just leave it like that. Meters per second equals final velocity. That makes more sense. 89 seemed ridiculously high. When something leaves your hand, it doesn't gain velocity, it loses it. Sure. Yes. This is what I did when I did that math. Was there other questions? We'll go through this again real quick. Oh yeah, it's still going. The negative 14 makes sense. What direction is this object moving after 5 seconds? Down. It's initially thrown up, right? Initially thrown up. It was going 35 meters per second. Every second, gravity takes away 10. So approximately how long for it to come to a stop? 3.5 seconds, right? Every second, it loses 10 from this 35. Every second, it loses 10 from that. So approximately 3.5 seconds off after that, it's come to its highest point. Then it starts to fall. When it starts to fall, the velocity is negative. So it becomes negative 14. If this object was thrown down 35 meters per second, then you would add those two numbers and get what I tried to do with 89, but that's not the case. All right, stop. This